Hello everyone, I am Somesha Shanapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So, in our previous classes, we have already solved so many numericals, but what's difference in these numerical is we have one moment here. So, this moment is about 80 kilonewton into meter, and also we have one point load and uniformly distributed load. So, first, before going to solve, we know that at end supports, we will have the reaction forces, that is Ra and here Rb. So, first work is to find out what the reaction forces. So, to calculate the reaction forces, we know what? The summation of horizontal forces is equal to 0 and summation of vertical forces is equal to 0. So, here Ra plus Rb going to be what? This 40 kilonewton plus here we have 5 kilonewton per meter. So, here we have distance is 2 meter. So, the load will be 5 into 2. Okay. So, Ra plus Rb, so 50. Now, let us go to calculation of moment. So, summation of m is 0 and we will have Rb into the whole distance. The distance is here 7 meter. So, Rb into 7 is equal to 40 into 2 plus 5 into, you can remember when we have one UDL, the formula for UDL is WL square upon 2. So, W is nothing but your load, L is your length and by 2. So, let us put that formula 5 into square of 2 divided by 2 multiply with this distance. Okay. Next, addition of the moment. You can ask why only moment, there is no multiplication of the distance, because already we have the moment here. So, we don't need to multiply the distance. T plus T, this Rb is equal to 180 upon 7 . We have 25.71. Seven one kilonewton. Okay. We can put this directly in this equation and we'll have Ra is equal to 50 minus 25.71. Here Ra is your 24.29 kilonewton. Okay. So we have the reaction forces, that is RA and RB. Next, our work is to find out shear force. So, step 2, calculation of shear force. Shear force is nothing but only the force what we have. So, as we have the reaction forces at the end supports, so we can directly find out the shear force, that is at RA and RB here. SF at B is equal to RB. Similarly, SF at A is equal to RA. The value is 25.71 and 24.29. 5.71. Okay. So next, at point C, here we only have the moment. So this shear force at C will not change. We only have this value. The shear force at C is minus 25.71. Next, here at point D. Up to this point, we don't have any forces. So at point D, we will have this value. It is minus 25.71 Newton. Okay. At E, we will have minus 25.71 here. Here the force 5 kilonewton into 2, that is 10 and this 40. So plus 40 plus 10. 50 minus 25.24.29. Next, shear force at A. We already have the reaction forces, that is 24.29. Now, our work is to find out and calculate the bending moment. Okay, calculation of bending moment is, there will be no changes, only we need to multiply the force with the distance. So, here at point B, we are having the value 25.71, but the distance you can see here is 0. So, multiplication of 25.71 with 0 will be 0. Okay. Moment at C. So, here 25.71 multiply with the distance. You can say distance is 1 meter and here 80 kilonewton into meter. One minus 80. So that is minus 54.29 kilonewton into meter. Next, bending moment at D here the distance will be multiplied, that is 2 plus 1 3 with this force. So 25.71 plus 3 minus 80. Here minus 2.87 kilonewton into meter. You need to always remember this unit while we are calculating bending moment. We are having the unit as kilonewton in meter, but while we are calculating shear forces, the unit will be in kilonewton. Okay. Bending moment at E. The similar process, but here we will have this load and this load. So this RB multiply with 5 5 minus 8 plus this 5 into 2 into 1. That is plus is 58.55 kilonewton into meter. Okay. Now always at end supports we are having the bending moment, that is 0. So bending moment at A is 0. Now we have the shear force and bending moment. Let's draw the shear force and bending moment diagram by using these values. Okay. So shear force at B we already have, that is 25.71. Let's take it here. Next, sorry, it is here you can see in negative sign minus 25.71. So This will be minus 25.71. Now, next minus 25.71 minus 25.71, then 24.29. So here go minus 25.71 kilonewton. So minus 25.71 kilonewton. Next 4.29. And reaction force at A is similar to the value of E, that is also 24.29. Okay. Next, let's draw the diagram. So, as we are having only the movement, so we will draw the linear diagram. Okay. While we are having UDL, we will draw parabola here. So, we will join this like this. Okay. Here is the value 0 here. So, what is 0 here and what happens at that and how to calculate? We will discuss that in next class. Now, let's go for drawing of bending moment diagram. So, we know at end supports we will have 0 here and here also 1 0. Next, bending moment at C, that is minus 24.29. Minus 24.9. Sorry, minus 54.29. Minus 2.87 and 58.55. And 87 and 58.55. And here 0. This is going to be like this. It will be joined as parabola. Okay. So here this part is part of your force diagram. This is part of your bending moment diagram. Okay. Here one new thing that we have, that is zeros here. So we will learn what is your zeros here and how to find out those points. So we will calculate that in our next classes. To know those things, you need to stay tuned. Thank you so much.